Hey there. As you can see from this first slide, this is from the CPM lesson 823. And what I'm going to do today is just introduce you to what's called the vertex form of a quadratic equation. The CPM book also refers to it as the graphing form, so I've heard it both ways, but I think more often it's called the vertex form, and I think the name will make more sense to you as we go along. All right, so the targets are really right here. First of all, I took this part right here. I took that title right from the book, 823. How else can I find the roots? So more ways to find x-intercepts, and then more ways to find the vertex is something I'm adding in. All right, so right here you can see that we have three different forms for equations that are the same. All right, so the standard form for the equation is y equals 2x squared plus 8x minus 24. And over here I have it in algebraic format and I have it in function notation. So that's one that we're used to. All right, we've been doing a lot of work on factoring. Right here, y equals 2 times x plus 6 times x minus 2 is the factored form for this equation. Right, and again, you can see it in algebraic format here. All right, but this third one here, this is the new one. All right, this is the same as this equation, but it's written in what we call vertex form. Now, you can see I did a little work. See where it says workspace down below? I think it got cut off a little bit by my toolbar, but what I did is I took this format and I actually did the math out. So you can see that what happens when I do that all out and simplify it, it does become the same as the standard form. So I just did that to show you that these three are the very same equation. They're just all written in different formats. All right, and each of them is useful in different ways, and that'll be the point of the next few slides, is to see how each of these can be really useful in graphing the equation. All right, so what I'd like to do is take a look at the same equation that we just did, and I'd like to look at its graph. All right, so what I did with this first one is I put it into Desmos Calculator in its vertex format. All right, now it doesn't matter which of these I used, I would still have the same graph. All right, so if you wanted to try it yourself, you could do that, and you would just see the graph comes up to be the same. All right, so then on this next slide, I have this. Desmos has this great feature where if you have your cursor on the same line as the equation, it will actually give you some of the key points. So it'll give you the x-intercepts, the y-intercept, which we haven't talked a whole lot about, and the vertex. All right, so what I'm going to do is point out from each equation how it helps you basically make a sketch of the parabola. And there's some good reasons every now and then to be able to make a sketch of a parabola. You'll actually use this quite a bit in physics. So what happens is you learn a little bit of math, and then it becomes applicable in a future course. So I think in this case we might have stumbled on that. Although at some point next week I'll show you a word problem from a physics class that uses parabolas, because parabolas do show up and all sorts of things. Like, for example, if you throw a baseball, the arc of the baseball makes a parabola that is downward opening. So all sorts of stuff like that in science. Okay, but right here, the standard format is really useful in helping us find the y-intercept. And you can see I'm circling around the negative 24. The y-intercept is what happens when x equals 0. So if you make x equals 0, you can see these first two terms are going to cancel, leaving you with y equals negative 24. And you can see from the graph right here, oh yeah, the y-intercept right here is 0, negative 24. The factored format, which we've been working on, is the one that's really useful in helping us find the x-intercepts. So remember, we set each of these equal to 0, because what we want to figure out is what is x when y is 0? Well, we can figure out that by setting each of these equal to 0 and solving for this little formula. So when x plus 6 is equal to 0, the x has to be negative 6, right? So right here, here's one possibility. When y is 0, x could be negative 6. The other thing is this could be 0 too. Relates back to the whole zero product property. Well, if this has to be 0, x would have to be 2. So sure enough, another option or another possibility when y is 0 is that x could be 2. All right, so this particular format of a quadratic equation is really useful in terms of finding the x-intercepts. You just basically factor it and then take the opposite of this term here. All right, but this one here, and the one that I plugged into Desmos, is really useful in helping us find the vertex. All right, so this term right here is actually going to be the y term. So you can see this right here. Oh yeah, it's down at negative 32, right? If you've got a negative here, you know that that's a minimum, not a maximum, because really the lowest this whole thing could be is 0. So if x is 2, basically if x is negative 2, but this is never going to be anything less than 0. So really, negative 32 is the lowest point you could possibly have. All right, and then basically for the vertex, we do want this whole thing to be 0. So we have to make this equal to 0. So x would have to be negative 2 in order for this to be 0 and to get our lowest point. Sal Khan does a really nice job explaining this, and one of the days next week I'll just have you listen to his video. He does a great job with this. But let's just say down here for now, if we wanted to find the vertex, see how this is a negative 2? You're going to take whatever's inside the parentheses here, and it's going to be the opposite of whatever this is, right? Again, it's kind of like this in a way. It's what gets you to 0. So sure enough, it's negative 2, and then it's this. All right, let's look at a couple other examples, and I'll try to point out what I did on these. Okay, so this one again, same quadratic equation, 3 different formats. Okay, the standard form helps you find the y-intercept. Yep, sure enough, 0, negative 8. So there it is right there. Factored form helps you find the x-intercept. So it should be at negative 4 and positive 2. Sure enough, negative 4 and positive 2. Right, and then the vertex format helps you find either the maximum or minimum point. This one is a minimum point again. Again, if it's a negative down here, it's going to be a minimum point. So it's going to be the opposite of this, which would be negative 1, and then it will be this, negative 9, and sure enough, it's negative 1, negative 9. All right, let's check this one out. This time I plugged it into Desmos using the factored form. Again, it doesn't matter. All 3 of these would give you the same parabola, right? So notice this, I've made them all open upward. I don't know why I did that. Next week, we'll take a look at some that open downward so we can have a maximum point. But right here, all right, it should be crossing at negative 15. Sure enough, crossing at negative 15. X-intercept should be negative 3 and positive 5. Yep, negative 3, positive 5, there you go. And then right here, I want to have the opposite of the negative 1, so that would be positive 1 for my x, and then my y is negative 16, and sure enough, that's what it is. All right, so the goal for today was really to see the 3 different formats for a quadratic equation and really see how each is useful in terms of graphing. Right? Next week, we'll talk a little bit about how you can go from this equation to the vertex format. You already know how to factor using the diamonds and rectangles or using the chart method, but this one involves something called completing the square that we'll do next week. All right, I took this page right out of your CPM book. All right, so I'd like you to take a look down here at each of these forms, and they actually tell you right in the book what each is used for. So here's the standard form, and they tell you that y-intercept is going to be 0, and then whatever c is. All right, so we discovered that on the previous slides. All right, then the factored form, right? The x-intercepts are going to be whatever negative b is and whatever negative c is. So basically what you're doing here is you're finding the opposite of whatever these two factored terms are, right? So there's that, and we've been working on that just a little bit. Okay, here's the new one, and again, the CPM book, for some reason, refers to it as the graphing form. It's most often called Vertex form, though. All right, so the vertex is going to be, all right, so note how they're saying h here. They call it negative h here, so I just say it's the opposite of whatever this term is, and then it will be k, whatever that is. Right, so again, that was the whole point of this lesson, is to get those three formats down, see how each of them can help you sketch a quick drawing of the parabola. All right, and that's it. So I want you to just answer a few questions on the Google Doc, get that handed in, and then I hope you all have a great weekend.